Chapter 19, Heparin Infusion Calculations. We've talked some about heparin before. You should know already that it is an anticoagulant. It inhibits new blood clots from forming, and it also prevents current blood clots from getting bigger. The reason that there's a complete chapter devoted to heparin is because it comes in various strengths, which we'll see later, and also you need to be aware that those varying strengths can make it very dangerous. Also, improper dosing can cause people to have serious bleeds, and so it's very important that we take a look at this. People get it after surgery. So they get it after surgery. Especially when they're going to be immobile and venous stasis. Think about how clotting occurs. It occurs when blood is no longer flowing. And so you can see how that could cause clots. Also, anyone that may just be at a potential, like they may have poor circulation, may be on a heparin, and then we will also see that we use it to keep a heparin lock open. Skip this slide. I didn't know how to get it removed. We've talked a lot about milligrams, we've talked about milliequivalents, and we've also talked about units. Heparin always comes in units. It may be administered subcutaneously or by IV infusion, which is a continuous IV infusion, or it may be an IV bolus, which is all given at once. Because of the potential dangers and adverse effects of bleeding, usually heparin infusions or vials are labeled in red so that alerts you to it being a heparin solution. Also, the administration of heparin requires that you frequently check lab studies. Those are coagulation times, which basically look at how long it takes a patient's blood to clot. And those are going to be very important to pay attention to. There are specific ranges of time that are acceptable, and those need to be watched carefully when a patient is on heparin therapy. As these various labels indicate, it is available in various dosage strengths, so you must be very careful when you read the dosages. These examples that are listed here gives you an example of 5,000 units per ml, 10,000 units per ml, that's quite a difference, 2,000 units per ml, and 1,000 units per ml. So you can see that if you grabbed the wrong vial and you wanted 1,000 units per ml and you grabbed a 10,000 units per ml, that could have serious consequences for the patient. When we give it subcutaneously, it does require a deep injection. You want to insert that at a 45-degree angle at least. It should not be aspirated after injecting the needle, and it should not be massaged after medication is injected. That will cause bleeding. Now, when you get your order for heparin, it may be ordered in milliliters per hour or units per hour. So you're going to have to pay attention to how it is ordered in order to do your calculations. You may use either an electronic infusion device or a micro drip. You really need to check your agency policy, because some agency policies are going to mandate that you use an electronic infusion device. It does require a dedicated IV line just for heparin, and we will talk about how to calculate these. Now, dosing is going to be based on current protocols. Those are set standards for certain For example, to keep a heparin lock open, an agency may have a set protocol that you flush the heparin lock once every 24 hours with 100 units of heparin. Also, it's going to be dependent upon the clotting time, which we talked about earlier, and then also dosing may be given based on a patient's body weight in kilograms. Due to the changes in clotting times during a heparin infusion, you may be required to change or titrate before the infusion is complete so that we are not overdosing the patient and causing the clotting time to be much longer, and then bleeding would be likely. Okay, here's the first example. You've got an order for heparin to infuse at 1,000 units per hour from a solution of 20,000 units in 500 milliliters per D5W. And so it asks us to calculate the milliliters per hour flow rate. So we know right then that we're going to start with our milliliters per hour. And really this is no different than what we've calculated in IVs in previous chapters. You do start with the two factors there because you have to end with milliliters per hour if that is what you are calculating here. Okay, so as I said, this is what we want to start with because it's what we want to end with. So we're going to have to set it up with our milliliters and our units. This is what we know we have. That's our available quantity. Then this is our ordered dosage. So we've got 500 milliliters over 20,000 units times our 1,000 units to be given in an hour. So what we have then is we can cross out our units, and what are we left with? Milliliters per hour, which is what we want. So if you take 500, and we could actually, this doesn't do it in this example, but we could certainly do some reduction of our fractions, and it would make it a little bit easier. But when you calculate this out, you end up with your answer being 25 milliliters an hour to deliver 1,000 units per hour. Our second example asks us to infuse 800 units of heparin from a solution of 40,000 units in 1,000 milliliters of D5W. Again, we're to calculate the milliliter per hour flow rate, so we're going to start with that, as we'll see on the next slide. So we start with our milliliters per hour. That means we set up our milliliters and then our units that we have in those milliliters. This is what we are using. That's our bag that we start with, and then that is times our order. So here's our order here. 800 units per hour. We do the calculations and we come out with 20,000 milliliters per hour. Again, what do we have here? Cancel out our units. We end up with our milliliters per hour. Do the math. Get our 20 milliliters per hour. Okay, this particular one is a little bit different. It is asking us to calculate the number of units infusing per hour. So what we have is an IV of 1,000 milliliters. It contains 40,000 units, and it's already infusing at 30 milliliters per hour. So what it's asking us then is to calculate how many units of heparin is this patient getting per hour. So in order to calculate that, what is it we want to know? We want to know units per hour. So that's what we start with, units per hour. Sorry, I lost my little thing, I'm using my finger, units per hour. So as you can see, we start with the units per hour. And what are we going to have in our numerator? We're going to have units. How many units are in the 1,000 milliliters? And so this is what we have right here. Then we know that it is infusing at 30 milliliters per hour. Again, what can we do? Cancel out our milliliters. We're left with units per hour. We do the math across, and it will give us our answer of 1,200 units per hour. Just to remind you, I have inserted a picture here of a heparin lock. That is an IV access line that has just been it's had a heparin lock inserted into it so that you still have IV access, but you don't have IV fluids flowing through it. Obviously, without IV fluids flowing through it, it could clot off. And so heparin flush dosages is what this particular slide deals with. Typically, it is 10 to 100 units per ml. 10 units per ml are used for peripheral access flush. You should know what that is, peripheral being in a peripheral vein. 100 units are used for central venous access flush. Our central lines are going to be in the larger veins, such as the jugular vein, and the end of those central lines are right at the superior vena cava. These should never exceed 100 units. And the next slide is from a previous chapter, but I think really fits better here as to why we have to be very careful about our heparin flush dosages. I don't know if you'll remember this, but in 2008 there was a lot of national news when Dennis Quaid, who is the actor, he had newborn twins that were in, as I recall, a newborn intensive care unit, neonatal intensive care unit, and got 2 successive errors in flush dosages, which caused the newborns to almost hemorrhage to death. He was very, very verbal about that, and even went to a congressional hearing to speak about the near death of his twin infants. And because of that, some changes came about. So I hope that you might even want to Google that if you never heard of it, but I hope that does impress on you that these were the nurse's fault, and these errors were a result of failure to correctly identify labeled dosage strengths. And so critical, very critical, that you make sure you know what the dosage should be to flush a heparin lock, and whether you've got the right dosage available.